We're going to go ahead and break down this GMAT Data Sufficiency question. And let's talk about the components first. You've got the question itself, which is here, asking us about this triangle. And then you've got two statements that are giving us additional information, statement 1 and statement 2. And then you've got your answer choices. And let's just go ahead and walk through those. A is saying that you only need statement 1 to answer this question. B is saying that you only need statement 2 to answer the question. So that means that this without this is enough to answer whether the triangle is equilateral. C means you need both. So you're going to need to know this and this in order to answer this question. D means that each of them individually can answer the question. So statement 1 by itself is all good, and statement 2 also by itself is all good. And then lastly, E means that even when you put them together, you still can't answer the question. First thing to do is to see if you can make any inferences here in the question itself. And there's not much to do. There's no algebra to simplify. The only thing I might think about doing is thinking about the properties of an equilateral triangle, just to make sure that those are really clear. And an equilateral has equal sides and equal angles. And so we're wondering, is triangle XYZ like this? Does it have equal sides and equal angles? Looking at statement 1, we know that 2 of the angles are equal. We don't know about the third, but we do know that 2 of them are equal. So let's see what happens when you've got 2 equal angles. Let's go ahead and call them both x, because we can change that y to x, because x and y are equal, and then the balance is z. So let's think about first whether we can make an equilateral triangle from this. And the answer is clearly yes, because if you just make z also equal to x, then you're going to have equal angles and equal sides. Now the question is, can we also make it not an equilateral triangle? And for this, I might just pick some numbers. You just want to make sure that you don't pick 60 and 60 for x, because then the balance will be 60 and it will be an equilateral. So just pick something else, let's say 70. That means this is 70, and z must be 40, because the sum of the interior angles of a triangle is always 180. So we've made a yes, we've made a no. That means that we can't conclusively answer this question, is XYZ an equilateral triangle? That means that statement 1 is insufficient. Let's go ahead and look at statement 2. Now z is equal to 60. So that's getting us somewhere, because we know that the angles of an equilateral triangle are each 60. And let's do the same thing. Let's try to think about, yes, it is equilateral, no, it's not. So starting with the yes, of course we can make these other angles 60, because when you look back at the question, we don't have any constraints. There's no limit for what x and y can be, so we can kind of pick whatever we want, as long as we keep the interior angles adding up to 180, because the angles of a triangle always add up to 180. So we have a yes. And then the question is, can we mess up the numbers a little bit to make a no? We've got our fixed 60 here. Can we split up the balance so that it's not 60 and 60? Of course, we can make it 70 and 50, right? We just need any 2 numbers that add up to 120. So again, we've got a yes. We also have a no. That means statement 2 is also inconclusive. So that means it's insufficient. And because statement 1 is insufficient, A is not possible, and statement 2 being insufficient means B is not possible. So let's look at C, and that is bringing your statements together. Now we know that this is x and this is x, right? That's statement 1, that these 2 angles are equal. The third angle from statement 2 must be 60. So if this is 60, the balance here, of course, is 120. And that balance must be divided equally between those x's, which means that they're each 60. The triangle is an equilateral. So because we needed both statements together, the answer is C.